Hey guys, how you doing? I just wanted to actually go over the problem that we did in class today, just so you can have one full video of it. This is the problem about right here. Let's just read it. An athletic trainer wanted to study the effect of being cheered for on athletic performance. To do so, he used 10 student volunteers. Half of the volunteers were randomly assigned to show up at the track to run 1 mile in the front of a group of their peers who cheered for their classmates as they ran in front of a group, right? And who cheered for their classmates to run. The other half of the volunteers were assigned to show up at the track at a different time when no one was there other than the trainer, who did not cheer for them. They also each ran 1 mile. On a different day, the treatments were reversed for each student. That key's right there. The fact that the treatments were reversed and each student had both treatments, that tells me right away I know it is paired, okay? If each subject gets 2 treatments, right here we know it's paired. Their 1 mile times were recorded again. This is in minutes right here. Here are the 1 mile times in minutes for each student. Also, of course, we see that as different, so we know immediately as paired. Okay, now, the trainer would like to estimate with 95% confidence the true mean difference in 1 mile times, the misprint by the book, for students like these using the no cheering minus cheering, using the order no cheering minus cheering. What is the appropriate inference procedure? So we said it's a paired T interval for mdiff because 2 treatments are given right here for the same subjects. So 2 treatments are given for the exact same subject right here. Okay? 2 treatments are given for the same subject. B, compute a 95% confidence interval identified in part A. Okay, so my state, 95% CI stands for confidence interval for M sub diff equals the true mean difference in 1 mile times, no cheering minus cheering, make sure I identify that. All right, and I'm going to put in units right here. So the units is right here, 1 mile times in minutes for students like these. Okay, so M sub diff is the true mean difference in 1 mile times, no cheering minus cheering, in minutes for students like these. Plan. First of all, name the inference procedure. This is a paired T interval for M sub diff. All right, if you said 1 sample T interval for M sub diff, that should be fine as well, I'm pretty sure, okay? But this is, you could, I guess the proper way is paired, but either one I think is okay. Random, okay, it says in the original problem, randomly, half the volunteers were randomly assigned to show up at the track. So I'm just saying right here, each treatment, so random assignment of treatments is what we have. 10% is not necessary because we did not do random sampling. Normal large sample, n is not greater than or equal to 30, right? My n value is right here. If you see 10 is 10 students in total, right? So my n is 10 as I put right here. So since n is not greater than or equal to 30, we had to do a dot plot. All right, so here's my dot plot right here. Notice right here, I went from negative 0.10 up to 1. Why did I do that? Well, if you look at the actual values right here, it looks like that my lowest is, my lowest right here is negative 0.05, which is right there. Oops, sorry. My lowest is negative 0.05. Not sure what's happening here, but anyway. There's my lowest, and my highest is 1. Okay, so the easiest way to do that is by 0.10, I think. If I'm looking at all these values right here, we have values all in between. So I went from negative 0.10 all the way up to 1. That's fine. And then I just went and plotted each point right there, all 10 of them, okay? So after you do that, you say no strong skewness or outliers. Okay, now we're going to go to do. So in this case, I'm using my calculator. I remember that it's a 95% confidence interval. All right, that's just my notes. I don't have to write that down. I'm just making sure I don't remember that. So I went right here. I go to my calculator. I go to stat, right? And I'm going to test. And this is an interval. So remember, it's T interval. Now, we have an option right here, right? If you notice right here, I have all of the difference values right here. So I could, one option is to go to stat, go to edit, and then put everything in L1, 0.10, 0.58, 0.451, etc. But I do also have the summary statistics right here, the mean and the standard deviation. So in this case, I'm just going to make my life a little easier for myself. I'm going to go to T interval. I'm just going to put in the actual sample mean difference and the sample standard deviation difference. So that's 0.45 and 0.331. My n value is 10, right? My confidence level is 0.95, and I calculate it. All right, so remember, for confidence intervals, I just had to put the actual interval and the degrees of freedom, which is 9. 10 minus 1, which is 9. So 0.213 to 0.687 degrees of freedom is 9, right? 0.213 to 0.687 degrees of freedom is 9. That's my do. Conclude. Okay. And so we always start out with confidence intervals. We are 95% confident because of, remember, it was a 95% confidence interval. We are 95% confident that the interval from 0.213, sorry about that, to 0.687, oh, this must have been based on the doing it by putting in L1, the L1 values instead of the actual sample mean at the end. Anyway, interval from 0.213 to 0.687 captures M sub diff. Yes. Now we have to define, what is M sub diff? If you forgot, you can either go back to your state. I said it right there, the true mean difference in 1 mile times, no cheering minus cheering in minutes for students like these. Or go back to the question. Right here it says, the true mean difference in 1 mile times for students like these using the order no cheering minus cheering. Either one works, all right? So I said the true mean difference, no cheering minus cheering, in 1 mile times, I just put minutes, for students like these, okay? And then we are done. That is it. That's all you have to do. So remember, go back to state if you forgot right here the definition of mdiff. You always put it in state also. So you're restating the state, essentially. Okay, guys, hope this helps. Have a good day.